Hello everyone, welcome back to a tutorial series part 17 for RAG powered AI application. In today's video, I'm going to explain how you can integrate another famous and mostly used database known as a MongoDB, which also known as NoSQL database or document database, where we store our data in the JSON format, which makes MongoDB as a flexible database where we don't have to stick to the specific structure which we have to in a relational database like SQLite in the PDF, right? So how are we going to achieve that? Before we get into the coding part, I would highly recommend you to watch part 15 where I explain how you can set up MongoDB along with loading the data. If you just watched my previous video, this is where we have a MongoDB container running and I'm inside the terminal. And if I run this command, we know that we have 733 questions and answer related to the system design concept, and if I just show you the complete structure, how the data finally looks like, probably I can just run this command, which is going to give us first 5 records. Right. So this is how it looks like, and this is how the data gets stored in a MongoDB. We have underscore ID, which is get added by the MongoDB. And these are the two fields where we have a question as well as the corresponding answer. Right. All these questions are related to the system design concept. Right. Now, what we're gonna do in today's video, let's quickly get to that part. So as usual, first we have to implement the backend part, right? So when we have to implement a backend part, obviously it's a database, so we have to make the connection and extract the data. We have to just convert the extracted data into the chunk, create an embedding and load to the Pinecone DB, which is a vector database. And then whenever user is going to raise a query, we are going to extract the context based on the vector similarity, which will provide us, the 10 documents, and that 10 documents is going to feed into the rewrite model to increase the accuracy of the context. And then we are going to feed that to the LLM so that LLM can provide the answer. In between, whatever the data we are going to upload, our application is provide us a summary as well as the five best questions which we can ask. So let's get into the demo part and see how we can do that. In today's video, I'm going to just use the refactored code, which I have done in a part 16. So if you haven't watched, I would highly recommend you to watch that so that you can understand. This is now the current structure which we have. So we have our refactored code, right? So we have this ingestion, then we have this RAG query, and then we have this services, right? So in ingestion, basically now we have to build another ingestion related to the MongoDB, right? So I have already written a code, which is a very standard code, which we have done for the Postgres ingestion or the SQLite ingestion. So in MongoDB, we need this Pymongo library. And for that, what we need to do, we have to just run a command pit install Pymongo. Right? That's it. This is the only dependency which you need. Once this is done, you have to thus import them. And the rest of the stuff is related to, the LangChain. So we need a document class, which we have been using in a Postgres and a SQLite. And then we need a Pinecone vector store, which is going to provide us a vector store through which we are going to load the data to the Pinecone DB. Then these are the functions where we are just initializing our embedding and the Pinecone. So these are just a simple, the functions which we have written when we did a refactoring of the code. So if I just go to the services and just show you the embedding details, you can see here embed and index document is the same function which we have in our larger file where we are just extracting an embedding. And we are just we are just loading the data with the help of an embedding to the index which we have on a Pinecone, right? Similarly, again, we have this initialize Pinecone client. Again, we have that initialization in the initializer code into the Pinecone. It's straightforward. We are using a Pinecone class, just feeding into the API key. Similarly, for the LLM, where we are having a large language model with the Google API. Then we have an embedding model with, again, the Google API key. We know all these things, and then we have a vector retriever, right? So these are just the initialization. I have just put it in the initializer. Embedding utils is going to just give us the embedding and just help us to load the data. Again, there is no need to make any changes in that. All we need is this MongoDB ingestion with the same structure what we have for the PostgreSQLite. Here, what we need to make a connection to the MongoDB. So we need host, port, database name, collection name, user, password, and the batch size. Because we know we have 733 records, which is going to, increase the limit which we have for the Pinecone DB. So I'm going to just reduce the number of record by using this batch parameter, which we're gonna see how we can utilize that. Okay, here we are just converting our string to the int because we are going to get this through the UI. So this is just a safest mechanism to just put in. So we are just converting into the into just mention. Now we are just making a client. So here we are using a Pymongo. Inside the Pymongo library, we have this Mongo client, which requires host, port, username. And this auth source is the database where our user is actually created. So we have to feed in the database name or through which we have just created our MongoDB. So let me just quickly show you that. Okay. Here is MongoDB workers, right? So this is our MongoDB user, password, and MongoDB database, right? So come back to our Python. Okay, so now we have this client. So we are just getting a client, and then this is just a command through which we are ensuring our connection is currently being made or not. This is just a way through which Pymongo provides us is master. If you just feed in this, and if there is no issue, then it means that the connection, there is no problem in just creating a connection. Once we have this client object, we can feed it as a database, and we can say, okay, this is the database we want to connect. So we are going to get the DB object. And then DB object, we have to just feed in the which collection we want to get data from. Then we are just getting this collection. And once we have this collection, then we know what we need to do. The rest of the process looks pretty straightforward. We just need splitting and the chunking and all this stuff, right? So we're gonna see. So now we are getting an embedding object, which we need to feed in here. And then with the help of this Pinecone vector store, we are initializing a vector store. Right? Now we have this get text splitter. Right, so we are going to just use this text splitter which we have here, right? So embedding util, I think I have already explained that. This is the get text splitter, which is a straightforward recursive character text splitter, which we are using feeding the chunk size and the chunk overlap, which we have defined in our config map, where we have a chunk size. So this is actually going to just split our text, right? Which is straightforward, right? Now everything we have just put in a function. That's the reason we are having this. Okay, awesome. So once we have this initialize, what we are doing, we are just finding. Find means this is a method through which we are just getting all the documents, right? So once we run this command, we will extract all the records into this Mongo cursor. And now we are just going to just iterate through the Mongo cursor to just get the document. And once we have that document, we know how to extract that, because these are the 3 columns which we have, which I just showed you by just extracting the data on a terminal. So we have 3 columns, 3 tags in a JSON like ID, question, and answer. And we are just, parsing that with the same. So MongoDoc is JSON, and we are just getting question, answer, and ID. Right, so we are just ensuring that, and then what we are doing, we are just creating a content. So when we are creating a content which we need to feed to our embedding for the Pinecone, so we are just converting. Okay, now we have another queue where we have this question and then we have the answer, right? So it's just a simple content which we are creating for every document. Then this is the metadata which we are creating, because we just want, now we have multiple sources, so we want to explain explicitly, okay, which source like MongoDB, Postgres, and then database collection, so that we can easily distinguish that, and we are just creating a document ID as well. Once we have this structure created like content with metadata, then we are just creating a batch docs, which we are going to control to load to the Pinecone. So we just get all the documents, converting the documents into this format with the content and metadata, and then we are appending this with the help of a document class, which we have got it from the LangChain schema, right? What it requires, it required page content, where we are feeding a content, and for metadata, we are just feeding a metadata, which we have just generated before this, right? So once we have this, we are just checking a length, and length has to match with whatever the batch size we have. And once we have that, then we are creating a chunk with the text splitter. Text splitter, I explained you, it's just a straightforward recursive character text splitter. right? And once we have that, then we are just checking whether it's the first batch or not. This is just a simple Python coding, and then we are just adding a document based on the batch chunk, right? So this is very straightforward thing to happen. And if you just bought, I just provide you the link of a GitHub where you can just get this entire working code and you can just run in your local. Once we have this uploaded, then we are just creating a summary, which is again a same logic which we have written in the past. We are just getting a summary for the generate document, and we are saying similarly we are extracting the best 5 questions, right? So I will just upload this in a GitHub. You can find the GitHub repo link in the description, and you can get the access to this entire code base. And this is what you have to do for the backend. Now we have to build a UI part, right? So for UI part, what you need is the very first thing is we need to import this new ingestion which we have created for the MongoDB. So that's the reason we have to import this. Once this is done, then we have to just create our Gradio-based UI. It's pretty much same like what we have built for the Postgres. The only difference here is the number of fields which we need. We need host, port, database, collection name instead of table. Then we need a batch size, right? And again, we have this MongoDB button, the same 3 fields like the status, summary, and the best 5 question. And then on click, we are just calling the same function which we have in the MongoDB ingestion, which require these number of parameters which we are feeding through the main app, right? And this is going to return us 3 fields which we can quickly verify here, right? So this is the return which we have. We have final status, summary text, and the suggested question text, right? Which is a completely the same standard which we have followed for the other data source, right? So now these are the changes which we need to make. And once we have this, and then we can just come down. We can just run our main app by just Python main app, and this is what we're gonna get. So let me just quickly change the setting, just make it dark so it looks good. Okay, so we have now added the 5th one, which is MongoDB ingestion tab. I click on that. This is localhost. Okay, this port is 27017. This is my database name. This is the collection name. This is my user, and I just copy password, and I want a batch size of 100. Let's click on this and come back to our server, and let's see what's going on. Okay, MongoDB connection is established, right? Namespace is cleared. It's okay. Pinecone vector is initialized. Text splitter is initialized. That's awesome. Starting a batch, fetching a MongoDB collection with the first 100 records, 200 records. So now we can just see the progress. Since we have 733 records, so it is going to run in a loop. First 100, second 100, third 100. So this is how it's gonna happen. Good. This looks good. 600. We can just go to the Pinecone okay. So process 733 total records. So all the 733 records just have 981 chunks, which just got loaded to our vector database Pinecone DB, right? So now what will be happening? It would be creating a summary as well as the suggested best questions, and that is where it is going to make the connection to the LLM. So now once this data is loaded, it just close the MongoDB connection. That makes sense. Okay. Okay, so now we can see on UI ingested 733 record, which resulted in a 981 chunk to the MongoDB collection name. This looks good. Then this is the generated summary which we have. This document discusses various concepts in the practice in a distributed system, focusing heavily on serverless architecture and microservice, key topics. And these are the 5 best questions which we can ask. So we can copy this one. Okay, and then we can come up here and we can just ask this question. What are the trade-offs between the consistency and the availability in the cloud application? Okay, so now we can see retriever configured to fetch our 10 result. This is based on the vector similarity, and then that would be the fed to the re-rank model. So re-rank is successful, return on the 3 top records. Once that is done, then it is just generating the answer. So we can just come here and we can see, okay, these are the contexts which just extracted by the vector similarity as well as the re-rank model combination, right? And this is what we are getting as the answer based on the provided context, the answer to the question. What are the trade-offs between this is not available. The context mentioned that the trade-off of different cloud and from services choice based on the cap requirement, but it doesn't describe what those trade-offs are. So it seems like, this batching is actually causing some issues. So let me just ask a very simple question. What is monitoring system? Just click on this. Let's come down here. Okay, so it's relevant results, initial result, LangChain, and answer, come out here. The context discuss critical matrix. Okay, let's come back here and let's try to see what we can just some distributed stuff fundamentals of this. Probably we can ask something related to something. Copy this one and ask this question. I think I have to change the logic. Okay. Cool. So startup benefits from the lower initial operational cost. Okay, what are the main benefits of serverless architecture for the startup? So this looks good. This is where, so it seems like I have to just fix the logic for the batches. It seems like when we are having this batching, it seems like, some of the data is not being loaded properly. So I will just check that and probably I will fix the issue. But if you also like to just contribute into that, that would be highly appreciated. But I would also try to check from my side by doing some research or some debugging, like why that is happening, why we were not able to get the answer of those questions, which was suggested by the LLM. Okay, probably there would be some difference the way I created the content, right? But that's pretty much it, which I wanted to cover in this video. So I hope you enjoyed this video, and if you really like this video, I would suggest you to give a thumbs up and share with your friends, colleagues, and groups if you feel this kind of video can help them. And please don't forget to subscribe for my channel, because that's really motivating me to just do more research, come up with a more advanced topic, right? So that's it from my side, and thanks for watching this. And as always, stay healthy and keep learning new things.